In this video, we're going to start with some chemistry basics. So why should we study chemistry? Well, it's central to our understanding of other sciences. We encounter it in everyday life, and all behavior that you see and experience is determined at the subatomic level. It's determined within those protons and neutrons and electrons. So because it does determine all behavior, we use it in biology and earth science, even in physics, so it's central to all of these other sciences. From a molecular perspective, if we define matter as anything that has mass and takes up space, or anything that has a mass and volume. So chemistry is the study of matter and its behavior. Elements are our most basic substances, and atoms are building blocks of matter. They are what compose it, they're what make up everything. So elements are one type of atom, and compounds are two or more atoms that are combined in specific shapes. So if we look at a picture here, this this little A is oxygen. So there are two oxygen atoms and they are exactly alike. Here we have water. So the red is oxygen and the white are hydrogen. So we have two hydrogens to one oxygen. Carbon dioxide. We've got carbon here is the black one, and the two reds again are the oxygen, CO2. Here's ethanol. There's some carbon in here, here's hydrogen, and here's oxygen. Ethylene glycol, which is antifreeze, aspirin. These are all molecules that are made up of atoms. So we can also classify matter as heterogeneous mixtures or homogeneous. And then homogeneous, we can actually go in and separate even more into pure substances and compounds. So if your matter is not uniform throughout, then it's heterogeneous mixture. We're going to be talking a little bit more in detail about these in just a few slides. So if you look at just a basic concept map of matter, you can see that it's divided into substances, which are your elements and your compounds, and mixtures, which we can classify as heterogeneous and homogeneous. And then we'll talk about suspension colloid, and then solution is another name for homogeneous. So let's start with elements. Pure substances that cannot be decomposed into something else, you have an element. And we've learned some of the element symbols, and we know that each element has a unique symbol that's one or two letters. When they have one letter, the letters capitalized, like hydrogen, boron, carbon, nitrogen, those all have one letter symbols, so we capitalize them. And if there's two letters in there, the first one's capital and the second one is not. Like helium is capital H, little e, beryllium is big B, little e. Elements are building blocks of matter. For example, they make up the Earth's crust, and it's mostly 5 elements, and you can see those on this chart down here on the left. And the human body is mainly 3 elements, oxygen, carbon, and hydrogen. So our elements are going to make up everything else. Compounds are formed when elements interact. The proportions are always the same no matter how the compound was formed. So we call that the law of constant composition, or the law of definite proportions. It tells us that the composition of a pure compound is going to be the same. For example, if we decompose water, there will always be twice as much hydrogen formed as oxygen. So the formula for water will always be H2O. It will never be anything other than 2 hydrogens to 1 oxygen. So here's another illustration of pure substances and some mixtures. So up here we've got red, which we saw represents oxygen. So we've got some oxygen atoms floating around. Here we have molecules. Nitrogen is typically blue. Here we have molecules of a compound. So this, I don't know what purple is, but this could be anything. It could be ammonia with a nitrogen and 3 hydrogens in there, but it's chemically combined. And then here we have a mixture of elements and compounds. So we have oxygen in there, we've got nitrogen in there, we've got whatever this guy is in there, just kind of floating around but not actually reacting together. So mixtures can be either heterogeneous or homogeneous. Heterogeneous are not uniform throughout. You can pick apart the pieces. Like, think about a tossed salad. You can pick apart the lettuce and the the cucumbers and the tomatoes and all that stuff. There's two special types. There's a suspension where you have two different phases and they settle out. Think oil and vinegar, okay, or muddy water. You're going to have that settling. Colloid is where you have particles that are suspended in air, like fog, where you have water vapor or water particles suspended in air. Homogeneous mixtures are going to be uniform throughout. You're not going to be able to see those pieces, and they're also called solutions, where you have a solute dissolved in a solvent, like salt water. You really can't see the salt and the water molecules, but you can separate them back out by evaporating the water. So homogeneous, you can't see the different pieces. Properties of matter can be described by physical and chemical properties. Physical properties are going to describe our physical nature of a substance. And we have two types, intensive and extensive, and we'll talk a little bit more about those in a minute. Chemical properties talk about the reactivity of a substance, and then we can also describe the changes in matter as either physical or chemical. So let's look at those in a little bit more detail. Physical properties are going to describe an object, things that you see, smell, taste, hear, or touch. Of course, we don't taste anything in lab. Extensive properties are going to depend on the amount that you have, like the size or the length, volume, or the shape. Intensive properties are intrinsic. They don't change with the amount, like melting point or boiling point. We're going to talk more about density later on, specific heat also. You know, melting point, it doesn't matter how much ice you have, it's always going to melt at 0 degrees Celsius. Water is always going to boil at 100 degrees Celsius. It doesn't matter if you have a cup of water or if you have a gallon of water. That's going to be its melting point or its boiling point. So chemical properties describe the chemical nature, the reactivity or the combustibility or the flammability. Reactivity is something like, we know that iron will rust if you leave it outside. You know, if you leave your bicycle outside, it'll rust. Combustibility, whether or not something will explode. Flammability, you know, whether something will burn. Physical changes are going to change the physical appearance, but they're not going to result in a new substance. For example, tearing or smashing or stretching, those things you're not going to get new substances. Phase changes are also physical changes. If you go from ice to water to steam, those are all H2O. Okay, ice is H2O, water is H2O, steam's H2O. So you haven't created anything new, you've just changed whether it's a solid, liquid, or a gas. Separation techniques are going to utilize physical properties. So things like filtration, when you separate a liquid from a solid, like when you make coffee, you separate solid coffee from liquid. Distillation, where you're using boiling points to separate out liquids. Chromatography is ink separation. Crystallization is where you use evaporation. It's personally my favorite because it makes rock candy. But we'll be talking a little bit more about these, and I'll show you a few of these in class also. Chemical changes are going to change chemical composition. You're going to form new substances, and we're going to use chemical equations to describe these. So on the left here, we have hydrogen and oxygen in a mixture. Notice they're not chemically combining. Then when we heat it up, we get water. So your hydrogen and your oxygen molecules are going to reform to form a totally new compound, which is water. So the 4 indicators of a chemical change, you do need to know these, so please make sure you stop and write these down. You're going to form a precipitate. A precipitate is an insoluble solid that's formed from 2 aqueous solutions. Evolution of a gas, when you create a gas, you have bubbles. Okay, that tells you a chemical change has happened. If you get heat or light, like a glow stick, you get light. That's a chemical reaction. Endothermic is where you feel cold because heat has been absorbed. Exothermic is where heat has been released. It feels hot. Color change is also an indication of a chemical change, but be careful with this one because it's not always an indicator. So just be careful. Usually color change is accompanied by another change.